Our next talk is Rory McCune, and he's going to be talking about getting started with Kubernetes security. So over to you, Rory.
Hey everyone, how's it going? Yeah, let me just get my slides up. Slides. Okay, awesome. Hopefully everyone can see the slides. Yeah, so the goal of this talk, or the reason I ended up giving this talk was every time I do a talk about Kubernetes security or container security, one of the questions I always get asked is, what's the one thing I can do for container security or for Kubernetes security? And I think that's quite a kind of common theme because a lot of companies, they're getting started with containers, they're getting started with Kubernetes, and they don't necessarily have a lot of time to think about the security side of things. So where do you start? And so that's the goal of this talk. What I want to do is go through some ideas about how you can think about security, some of the things you can think about how you can think where you need to spend your focus, your time, and then talk a bit about some quick wins, some things you can do quickly and easily to improve your cluster security. So before we get started, just very brief about me. My background is information and IT security, working in financial services, consulting, a number of places. Last 10 years, I've been a pen tester, so kind of basically breaking into systems. In the last 5 of those, most of those systems were Docker-based or Kubernetes-based, lots of container work. These days, I am a cloud-native security advocate for Aqua, and that basically means that my job is, well, doing things like this, right? Trying to help the overall position of cloud-native container Kubernetes security. One of the things I do as part of that is I'm an author of the CIS benchmarks for Docker and Kubernetes, which are a useful resource for hardening both of those platforms. I'm also a member of Kubernetes SIG security and also the only unofficial Kubernetes SIG, I think, to have done a keynote at KubeCon, which is SIG Honk. And we kind of focus on like hacking and playing around with breaking into clusters. As you can see from the sticker on the right-hand side, you might guess that I'm based in the Scottish Highlands, as that's a Highland coup breaking out of a container. And I stay here, which is Loch Goilhead in the West Scottish Highlands, just west of Loch Lomond a little bit, which, as you can see on a nice day, looks really lovely. And actually this summer, we've had loads of nice days. I think we sent our rain down south this year, because usually it rains here pretty much all summer, but actually we've had lots of nice days. So nice place to visit if you get a chance. Anyway, let's get started on the talk. The first thing that I wanted to talk about, or the first thing I think you need to think about when you are getting started with Kubernetes security, is how much resources do you have to do this, right? Do you have like this, you've got like a squad of people who you can dedicate to doing all the different activities you might want to do. You might want to do image management and container security. You might want to do service mesh security. You might want to do hardening. In an ideal world, you would have resources that look like this. You'd have lots of people to do all the activities you need. But let's be realistic. For most people, they've got a lot of work on. They've got a lot of different things to think about. And the primary focus is going to be making things work, right? It's going to be getting your cluster working, getting your applications working, and keeping them working. So when it comes to security, your resources probably look a bit more like this, right? You may have, if you're lucky, a full dedicated person. You may just have a bit of someone else's time. When they've got something running, they may have a bit of time to work on hardening. It may be something people have to work around as part of their other responsibilities. And this is why it's really important to think about where you get started and targeting your resources well. Because if you haven't got a lot of people to spend, you don't want to spend that little time that you've got doing things that don't really improve matters. How do you go about doing this? This is what I want to talk about is how can you actually do that? How can you think about this, try and make sure you're targeting those limited resources in the right place? So here's how I would do it, or how I do it. First thing you need to think about is your threat model. Now, threat modeling is, there's whole books written about threat modeling, but really when you're getting started, you can think about it like this. A threat model is who is going to attack me? Who is going to attack my Kubernetes clusters? Who is going to attack my applications running in those clusters? Because once you think about who is going to attack you, and you think about how they might do that, it gives you an idea of where you need to start on the defensive side. With Kubernetes clusters, I tend to think of 3 threat models. So you can just think of which of these 3 apply to you. The first one is, if your clusters are on the internet, or the applications that they host are on the internet, then you need to worry about internet-based attackers. There are people on the internet scanning around the internet looking for vulnerable systems all the time, using automated scans or manual attacks. If you're on the internet, you need to worry about them. There was some research done by we've got kind of a threat research team called Nautilus, and their latest statistics were that from the time a vulnerable system, in their case a Docker daemon, was put on the internet, to the median time to attack is 50 minutes, so less than an hour. So if you put a vulnerable system on the internet, then you have about an hour before it's likely that someone's going to find it and try and compromise it. So that's the first threat model, and most clusters probably have to worry about that. The second one is compromised containers, right? If you've got, say, 10 or 20 applications running in a cluster, statistically, it's likely one of them is going to have a vulnerability, right? Applications have vulnerabilities. And it can get exploited. And when it gets exploited, your attacker is going to land in a container inside the cluster. So if you've got the kind of setup, you need to worry about the sort of things you would do to protect against someone once they've landed in a container from going around and trying to compromise the cluster. The third one is compromised user credentials. So if you've got a lot of users in your system, or if some clusters are even worried about like users not being able to get too much access, then you might need to think about that as well. So you might need to think, well, if I've got a lot of users, how do I lock them down? How do I stop them from getting more access than they should have? But in some cases, you might not need to worry about that. So if you have, for example, a cluster which feeds all its containers through a CI/CD pipeline, and you have a single user, then you probably don't need to spend as much time on those kind of attacks. I'm not saying in an ideal world you do nothing, but realistically, when you have that small quantity of resources, you don't start there. And with the other one, with compromised containers, if you have no externally facing applications in your cluster, maybe they're all internal batch processing applications. Again, maybe you don't have to worry as much about compromised container attacks, and you can focus purely on that kind of external hardening piece. So thinking about threat modeling is useful, just in that basic way of what do I need to worry about, to give you an idea of where to start. The other thing when you're thinking about where to start is you need to think, where can someone attack me? And this gets called attack surface. Basically, that means what is exposed that the people I'm worried about attacking can get to and can try and compromise. So if your clusters are on the internet, they are obviously part of your attack surface. If your applications are on the internet, they're also part of your attack surface. But there's other things that might be less obvious that can be part of your attack surface, which would be things like container registries. If you have a container registry, you're using Docker Hub for your production images, your Docker Hub accounts are now part of your attack surface. If an attacker gets access to your Docker Hub credentials, they can push malicious images, which are then pulled down into your production clusters. Your CI/CD systems, you're using a cloud-based CI/CD system that's on the internet, that is part of your attack surface. We know that attackers will attack CI/CD systems. We know that they try to compromise them. If you use those, then you need to concern yourselves with both how you get access to those CI/CD systems, but also the security of those platforms themselves, because they've got security problems too. So attack surface is an important one. So that's who's going to attack me. That's where they're going to attack me. Now, how do you think about how do I want to take that information and turn it into where I start? And for this, this is possibly the most important slide in the presentation. It may not look like that, but I think it is. The way I would suggest you want to take that information that you've thought about, who's attacking me, where they're attacking me, and think, where do I start now? You're looking to improve your mess up tolerance, M.U.T, mess up tolerance. The idea here is mistakes happen, right? Configuration errors happen, user error happens, CVEs in code happen. These are inevitable. What you want to try and avoid is a situation where a single mistake, like a single lost set of lost credentials, a single bug in a program, a single vulnerability, can cause a security incident in your environment. That's why I'd call a mess up tolerance of 1, because if you have a single mess up, you have a bad security incident. What you want to try and do is get to the point where it would require 2, 3, 4 incidents all to happen in the same area for you to have that security incident. I'll give you a worked example, just try and make that a bit more real. Say you have a Kubernetes cluster, right? And you have it on the internet, right? The API server is exposed to the internet. Now, that is a moderately common configuration. There's several 100,000 Kubernetes clusters sitting live on the internet at any given point in time. And there's some search engines you can go to look around them all if you want to. And then say you have anonymous authentication turned on your API server. Again, this is a moderately common configuration. Indeed, it's a default configuration for some cloud cluster providers. So in that situation, you've got anonymous auth on, API server on the internet. If you make one RBAC mistake, so say someone applies a Kubernetes manifest to that cluster that says bind cluster admin to the system unauthenticated group. Now that's a mistake, that's a bad mistake, but it's a single mistake. And if you have that configuration and then you bind that bad manifest, your cluster is going to have a bad time, right? The attackers will find it quickly, they will compromise that cluster. Now, how would you improve that? Well, if you took anonymous authentication off, say your cluster doesn't need anonymous authentication to be enabled, you've got other ways of doing things like metrics. At that point, you now have a mess up tolerance of 2, because someone's going to need a set of credentials and they're going to need the rights to do it. So you now have 2 things that probably have to go wrong at the same time for you to have that security incident. Then say, for example, you take your API server off the internet. You don't have it exposed to anyone. Either maybe you limit the source ranges that can get to it, or you put it behind a VPN or an SSH bastion, or your cloud's remote access service, which most clouds have got these days. You've now got a mess up tolerance of 3, because someone's going to have to compromise your bastion or your remote access service. They're going to have to get valid credentials for your Kubernetes cluster, and they're going to then have to get the rights to actually deploy whatever it is that they want to do. So just those simple steps can take you away from a situation where a single vulnerability in the Kubernetes API server, for example, there could be a CVE tomorrow in the Kubernetes API server. If your clusters are sitting there on the internet, you might have a mess up tolerance of 1, and that could obviously be very bad. So for my money, if you're getting started, that's a great approach. Think about the places where 1 mistake could give you a security incident and try and start there. Start trying to get those numbers up. You just even get up to 2. Yeah, get all the places where it's 1, try and make it 2. So that's one way of doing it. So with Kubernetes though, how can we do that? Where are the things that we can apply to make that happen? First thing to do is to think, can we reduce our attack surface? And then when I originally showed attack surface, I had the big, huge castle with all the different ways in, loads of windows, loads of doors. Can we reduce that? When you reduce your attack surface, you're lowering the number of places where you have to spend those limited resources, right? So you don't have a huge number of resources. Very few companies do. You're trying to say, where can I focus? If I have 500 points of attack, I have 500 places I have to worry about, 500 places to spread my resources across. If I have 5, I can focus all that same effort in 5 places. Therefore, I can put more effort per place. Lower the attack surface, the better you can focus your security efforts. With your limited resources, the more chance you'll have of avoiding something bad happening. How can we do that though? Well, let's talk about some of the real kind of things you can do for that. We'll start off with quick wins. What are the quick wins? The things, those like you want one thing to do. What can you do as the one thing? Don't put your clusters on the internet. Some people who are watching this may be thinking, well, that's obvious. Why would I put my Kubernetes API server on the internet? Other people will be thinking, all my API servers are on the internet. As I said, there's about 400,000. It's something around that mark. I haven't checked in the last couple of weeks. Kubernetes API servers directly connected to the internet. You can always spot an API server based on the TLS certificates that it presents. There's also tens of thousands of clusters online with anonymous authentication enabled, because you can go and look at the version endpoint and find out what version of Kubernetes they're running. If your cluster API server is on the internet, you potentially have always got a mess up tolerance of 1, because a 0-day attack, an unpatched vulnerability, the Kubernetes API server, and your cluster could be compromised. Getting that off the internet, if you don't need it, you can limit IP address ranges if you need systems to be able to talk to it. You can put it behind a bastion, a VPN server. There's options you've got there. But if you can get that off the internet, you're reducing your attack surface for sure, and you're getting their mess up tolerance away from being 1. That's the first thing I think that's worth doing if you can. New clusters up's easier. Existing clusters, you might need to look at what might be using that and rework it. Second one, use managed Kubernetes if you can. When you use like a managed service, so like something like GKE, AKS, EKS, you get this shared responsibility model where the cloud provider will take on some of the responsibilities for security. So with Managed Kubernetes, that typically means that you no longer have to worry about those control plane nodes. You don't need to worry about patching your control plane either, because both of those things should be done for you by the cloud service provider. So that's reducing your attack surface because it means someone else has to manage that. Now, obviously, you're trusting that they will handle that, but it means it's something else you don't have to worry about. You don't have to think about, right, how have I hardened my API server nodes? How have I managed to patch the API server, et cetera, et cetera? You can let them handle that. So if you can use Managed Kubernetes, you can focus on other areas that aren't, they're now handled for you by the cloud provider. So that's another one. Don't mount service account tokens unless required. This is when I look at Kubernetes defaults and I look at kind of the security defaults, this is what I would love to have changed. By default, Kubernetes will mount a service account token into every pod that is created in a cluster. The vast majority of application workloads don't need to talk to the Kubernetes API server and therefore probably don't need a service account token. Therefore, you can remove it. So you can remove it at the pod level. You can tell the service account not to mount the service account token by default, and then only mount it where specifically required. And you say, well, by default, it doesn't have a lot of rights, and that is true. But I've seen third-party products for Kubernetes that I saw one, for example, that bound, as part of its installation mechanism, it bound the default service account token in the default namespace to cluster admin. That means that any pod that was in that namespace and used the default service account token had cluster admin automatically, and any person who could create a pod in the default namespace got cluster admin for their workloads. Mess up tolerance of 1 again. If you don't have that service account token and you apply that manifest, you are not going to have as bad a time of it. It's less likely that someone will be able to compromise that. It also gives you time to notice that's happened and try and go, hey, you didn't mean to do that. That's a terrible idea. But don't mount service account tokens. That one should be fairly easy. Unless your workloads are using it, which you would probably know about, you can, get rid of that. So there's also some things which are high impact but harder. These are things which aren't as easy to do, but which, if you can do them, will have a big impact on in this case, your attack surface. Default deny network policies. By default, every Kubernetes workload in a cluster can talk across the container network to every other workload. This means that if someone can compromise one container, they can scan the whole container network. So when I was a pen tester and I did a compromised container assessment, so where I start with a compromised container, my very first thing to do is install a port scanning tool, scan around the entire container network, looking for other services to attack. And what I typically found was that people would assume that things installed inside the container network were on a trusted environment, and they maybe didn't have authentication turned on by default. So that gave me other things to go and attack. If you can turn on a default deny network policies, this is harder because it means when you're developing applications, you need to think, what other services does this application communicate to? And then you need to write network policies that imply that make that the case, so that you know that when you deploy it, you'll get the network policies you need to talk to other systems. So it is harder to do, but it does have a big security benefit if you're worried about compromised containers. Again, if you're not worried about that scenario, you maybe don't need to do this as much or as early in your process. But if you do, it's a good change to make. So in addition to reducing the attack surface, we can also harden things up. We can improve on the security defaults that are given to us by our container runtimes and by Kubernetes in ways that will essentially make it harder for attackers, will improve our mess up tolerance, and kind of make it more likely our clusters will be secure from day to day. Again, let's look at some quick wins. Let's look at things you can do easily that shouldn't have any impact on your working practices or your existing clusters or applications, but will improve things. First thing to talk about is security context and workloads. This is as an application, if you're an application developer or you're an application owner, one of the best things you can do is set security contexts on your workloads because you're essentially making it easier for you. You're reducing the privileges given to the application when it's deployed. And you are helping also, if you then go on to do things like admission control, you're making it easier for that to happen because the applications already have the security settings they need in place. So everyone's clear about what's required for this application. A couple of easy ones to set. Security context, privileged false. Privileged containers are very dangerous. You should never use privileged containers unless you absolutely have to. explicitly setting this as false just makes it clear that you don't need that and you don't want it. It means if you're using infrastructure as code scanning tools, that you can clearly see which ones have got it, which ones don't. The default is that it shouldn't be on, so it's not as bad if you don't have it set, but I always recommend as a nice, easy, if you're doing templates for your application manifests, put in that security context, privileged false. Makes it really clear to everyone that you don't need privileged containers. Another one to set that should be relatively easy, relatively low risk, is allow privilege escalation false. This one's not on by default, so this is worth setting. What this basically says is, if I start my container as a non-root user, don't allow it to get more privileges once it's running. Don't allow it, for example, to sudo up to root. That should be fairly safe. I don't think I've ever seen an application that starts with low privilege and then tries to get more privilege inside the container. I've seen applications that do the reverse. So maybe they start as a privileged user and then drop to an ordinary user, like I think Nginx does that. But I've never seen the reverse. So this should be relatively safe, shouldn't be a problem. If you put this in your application manifest templates, you have a setting which should improve your security. In this section, there's quite a few things that are harder, but high impact. Things that are, if you have that extra resource, maybe you've got some additional time, or you're planning something out for the future, definitely worth considering. Security context and workloads. Previously, we talked a little bit about some easy settings, some things that aren't super complicated, shouldn't be impactful. There are other things you can set which do require more effort, but are significant benefits. Don't run as root. Containers running as root is not a great default from a security standpoint, but they do. So you need to do the work for this one. So essentially, you need to work with, when you're developing your container images, to have them run as a non-root user. So setting a user, making sure that the application can build and run okay when it's not root. When you've done that, then you can set these settings in security context to say what user ID and what group they're going to run as. Don't explicitly use that 10,001. That's just one I picked out as an example. The reason this is important is if you run your containers as root, there is more of a chance of a breakout. Whilst your container runtime, like Docker, will constrain root, so it's not completely unconstrained, there have been several CVEs now where the first line of the CVE is this only works if the container runs as root, right? So it will reduce the risk. If there's a CVE and you've got that mess up tolerance, you say, well, if I'm not running any of my containers as root, this is less likely that this can ever be exploited. In some cases, it actually might not be possible to exploit. So this is a good hardening setting, but it does require more work because you have to look at it for each application and make sure that it can run as a non-root user. Read-only root file system, setting it to true in the security context. So here, containers are meant to be ephemeral, right? Containers are not meant to store state inside the running container. They're not meant to store any persistent data. So you should be able to set the read-only root, the root file system to read-only. You do need a bit of work because if your container needs to, for example, write temp files or log files, you need to make sure those are mounted in with like an empty dir volume. But fundamentally, this one will frustrate attackers. What an attacker will do typically when they compromise a container is they will put their tools, some sort of binary, some sort of malware into the container so that they can then carry on doing what they want. If they try to do that and it fails because you have a read-only root file system, it will either slow them down while they search around looking for the writable file path, or it might stop them. If it's an automated scanner, it tries to drop the tool, it doesn't work, the scanner moves on to the next host. So you can actually save you from attack setting read-only root file system. But again, does require a bit of work. Last one, cap drop all. Essentially, whenever you run a container, Docker or the container runtime will give it certain capabilities, which are parts of root's privileges. If your applications don't need those, you can drop them all in security context. Say drop all, don't give me any of these rights that I don't need. Docker chooses like a kind of what they felt, and they're probably right, was a sane default that would work for everyone. But a lot of applications, especially if you're not running as root, don't need any capabilities. Also, until recently, you might have needed capabilities to do things like bind low ports. So to bind like port 80, you had to have capnet bind. You don't anymore because in Docker, it sets a sysctl, which says you can bind unprivileged ports, low ports. And in Kubernetes 122 and above, you also have exposed that so you can set it in security context to say allow a non-root user to bind the low ports. And if you do that, then you can do this, get rid of all your capabilities, and it's going to make attackers' life, again, harder. If they land in a compromised container, they're going to have less chance of breaking out to the underlying machine and then giving you that bad security incident. But it does require a bit more work. You do have to think, do any of my containers expect to have a specific capability? Some other things, harder, but absolutely worth doing. Admission control. So security context is a voluntary mechanism. Every manifest can set it. If you're worried about either compromised user credentials, or you're worried about potentially you want to restrict the rights of your users to do specific things, you're going to need to mandate those controls. You can't rely on voluntary security context. And to do that, you need some form of admission control. In the past, we would have said pod security policy would have been the approach to take. As that's being deprecated, you should be looking now either to the new pod security admission controller, which is coming into beta in 1.23, or look at external ones like OPA or Kyverno, things like that. Use those to enforce your policies, and use those to enforce things like read-only root file systems, non-root users, and stuff like that. Again, this isn't the high impact but harder, because fundamentally this is going to require you to probably go and get a piece of third-party software to implement it, make sure the rules are running right, make sure it doesn't impact your clusters. But if you have a multi-user cluster and you are worried about that threat model, you should do this. Again, if you're not worried about that threat model, you probably don't need to do this as early. Still ideally it would be good to have, but move it down the priority list a while. Least privilege RBAC. This is another one, only really matters if you've got, again, lots of users in your cluster and you're concerned about restricting their rights and making sure they can't do things they shouldn't be able to. This is quite difficult. And one of the reasons why, if someone says to me, I want a really tightly secured cluster, I say, well, try not to give people Kubernetes API access. Kubernetes RBAC has quite a lot of kind of like edge cases, things which are maybe not intuitive, but could cause security leaks. If I was giving simple advice about RBAC, the two things I would say is avoid cluster admin. Don't give people cluster admin. That's a terrible idea, because it allows them to do everything. And you probably didn't need them to do absolutely everything in your cluster. It also means that if you have a mistake, someone mistypes something, that they delete namespaces. Well, if you didn't give them the right to delete namespaces, they can't do that. The other thing I would say is try to avoid the built-in cluster rules, things like view and edit, because they're not very fine-grained, and they might give you access to things that you didn't expect them to give access to, and give rights you didn't expect. Always, when you're doing RBAC, try and think, what does this person actually need to do, or what does this service account actually need to do, and give it as fine-grained as possible. It is in the harder category because that does require work, but it's important if you're worried about the kind of user access side of things. Last one I would mention is internal container registry. When I was a pen tester, the finding I pretty much always gave in every single report was you are using images that are from random users on Docker Hub, right? You've downloaded not one of the official images, but some person's random image. Now, Docker Hub is entirely uncurated outside of the kind of official and vendor-based images. If you're pulling those images, they could be anything. And it also means that the third-party developer whose image you're pulling, their credential management is now part of your attack surface. Because if they lose their access to that account, their password gets stolen, their accounts get stolen, that's now your problem, because you're pulling their image into your cluster. The best way to get around that is to have an internally curated set of container images that you manage yourself in your own container registry. It doesn't need to necessarily be on-prem, obviously it's in the cloud, but something that you manage, that you control. And that gets away from that problem, because then what you can do is use admission control to say only allow images that come from our internal container registry. And that's going to essentially harden the setup quite a bit. But again, this is more work. You have to implement container registry, you have to manage access to it, you have to get all the tools and everything else set up for it. But for my money, that's somewhere that's worth looking into. So a couple more resources, a couple of tools which could be useful when you are doing your when you're doing this kind of work. First one is these are all open source tools. First one is Kubebench. Kubebench allows you to scan your clusters and compare them to the CIS Kubernetes benchmark. So just a quick way of saying, what settings do I have that I might want to look at? With the CIS benchmarks, one thing I would say is don't necessarily think I have to do everything on this benchmark, right? That's probably not necessarily, realistic, but it's definitely somewhere to start. The other tool is Trivy. You may know Trivy as a vulnerability scanning tool. So for scanning images for outdated software, it also does IAC scanning. So you can scan your Kubernetes manifests and you can come back with like things that are wrong, like you've got privilege set or you haven't dropped capabilities. And that's a tool that can be used on any machine. So it means that developers, when they're writing manifests, can scan their manifests against Trivy and say, what do I need to consider in terms of actually securing that down? And you can customize the policies as well. So, conclusion, think about your threat model. You're trying to think, you've got limited resources. Think about who is it you're worried about? Who do you think is going to attack you? And think about where can they attack you? Because that's where you need to focus your efforts. Improve your mess up tolerance. Best way to do this, try and improve your mess up tolerance. And there are some good quick wins to improve things. There are definitely some things you can do which will make things better. So that's all my slides. Hopefully that was useful. You can grab me on Twitter as @Racine or in email at that address there. And I'll be in Slack if there's any questions.
Thank you very much, Rory. That was very informative. Yeah, we actually have one question from Tim Bannister, which is, when Kubernetes adds support for enabling swap on nodes, how does that affect information security?
I'm not sure I can think of an immediate impact. I mean, there might be something with availability where it's going to improve things by, you have less likelihood of getting denial of service. That's the only one that kind of springs to mind. That's a tricky one. I'll maybe give that some thought.
There was one other question that I was thinking about, which is essentially I've heard lots about VM isolation with something like Kata containers and how that could have an impact on security. What's your opinion on that? What are your thoughts about a project like that?
If you're trying to do something like hard multi-tenancy, so I've got like untrusted workloads I'm running in containers, yes. Either something like gvisor or something like Kata containers or Firecracker. Linux, Docker, kind of CRI, it does a decent job of isolation, but I wouldn't rely on it against hostile tenants. And we've seen several CVEs. There's been CVEs in RunC that have essentially allowed you to break out to the underlying host file system. It's quite a complex stack, and there's all these layers. You RunC, containerd, then you've got Kubernetes, and they all need to line up their security primitives, which is a challenge because you get different groups managing each of those. So if I was worried about, like, I've got hostile tenants, absolutely, I'd be looking at either gvisor or Firecracker or Kata containers, for sure.
Cool. All right, any questions from you, Chris?
I just one question. You talked earlier about vulnerabilities and so on, and it seems like, I think, as you said, almost all containers have some sort of vulnerability or will have some sort of vulnerability. Any advice on kind of anyone watching where to start with that? Do you threat model those vulnerabilities? How do you start categorizing them in what's priority to fix?
I think the thing I would say is the best thing people can do if they're getting started for container vulnerabilities is try not to install software you don't need in containers. The less software, the less vulnerabilities, the easier it'll be to pick ones. Then if you've got time and there's ones you can't easily patch, look for things that are remote exploitable. CVSS scores will have this thing about whether they can be exploited remotely. They're not always perfect because they don't know about containers when they write these scores. So it might not be applicable. So it is a bit tricky because you have to dive into each vulnerability. And that's fine if you've got 5, but if you've got 5,000, you're not going through each one and going do. That's why I always say the easiest thing, try and get rid of any software you don't need, because then you don't have this massive list to work from. And it's kind of that attack surface piece, get yourself down to a couple so you can actually focus in and go, what do I do here?
No, great advice. Thank you. Great.
Cool. So we're going to take a break for lunch now, and we will be back in just over an hour for the restart of track 2. So we'll see you then.
Have a good break. Thanks all.
Bye.
Bye.